Hello, my name is Indranil Basak and I am a PhD student, and my research topic is on inkjet printing of stretchable electronics for 3D forming application. The main advantage of inkjet printing is it is a cost and time effective technique. It can print a pattern with high resolution. It is easy to use material deposition technique. This is a Dimatix inkjet printer from Fujifilm. It is a piezoelectric based technique. It is specially designed for research and development testing. Ideal application for this printer is deposition of functional material on rigid, flexible and stretchable substrate. In this system we draw the pattern by Illustrator. So you can see this is the Illustrator software, and then we draw one pattern, one rectangle, and then send the pattern to the printer software for inkjet printing. After printing, we use annealing or drying the pattern within oven. The nozzle diameter of the printer is around 21 micron. So this is a printer nozzle, and you can see this there's a nozzle. It is 8 by 8 nozzle. Total 16 nozzles are there. So all the nozzle diameter is around 21 micron. And my challenge for this system is formulation of an ink that can jet smoothly from the nozzle. It is limited for Newtonian fluids only. In general, the ink with viscosity 10 to 12 millipascal can jet without blocking the nozzle. My PhD is on printing of functional materials on stretchable substrate. Rigid and flexible substrate cannot be used for 3D forming application. I am printing conductive polymer P.PSS on thermoplastic polyurethane based substrate. P.PSS is a functional material that can stretch after printing and drying. Now I will show you the printing process and the integration of conductive pattern on 3D geometry for touch sensing application.
So here I will explain the drop-on-demand inkjet technology. The basic principle of this technology based on a drop-on-demand means printer ejects drops if a drop is required. In figure 1a, computerized data image is created by Adobe Illustrator software. Then the data image is sent to the printer software. Inkjet printer software creates the image by droplets, as you can see in figure 1b. Then by connecting drops, a uniform layer is formed. To print a uniform layer, drop spacing plays an important role. In figure 2a, drop spacing is too large so that drops do not connect with each other. In figure 2b, drops connect with each other but still not at the right position, so that waviness around the edges is noticed. It is called scalp drops. In figure 2c, drops are placed at right position so that it forms a uniform line without waviness. In figure 2d, drops are too close with each other so that bulging is noticed. In this technology, it is important to adjust drop spacing carefully to print a uniform layer. Drop spacing can be adjusted by printer software. So first, drops of conductive polymer P.PSS are ejected from the piezoelectric based inkjet nozzle. Then drops with right drop spacing deposited on stretchable thermoplastic polyurethane based substrate to print a uniform rectangular pattern. In the next step, substrate is stretched with conductive pattern. We used P.PSS as it is cheap, easy to formulate and stretchable conductive material. For stretchable application, both substrate and conductive material should be stretchable. So in the last step, stretched conductive pattern integrate on 3D printed cone by vacuum forming method for touch sensing application. as you can see in figure 3. Figure 3a, photo images of vacuum form touch sensor without touch, and in figure 3b, LED glows with touch.